Hello, this is Sean McGowan doing my video submission for ENME 351 Lab 1. For this lab, the purpose is to show how digital logic circuits work and to show how we can use those circuits to create 2-to-1 multiplexers, and then using those 2-to-1 multiplexers to create 4-to-1 multiplexers. In this lab, we got a lot of hands-on experience with and/or inverter chips as well as our Arduino boards and LEDs to create a physical 2-to-1 multiplexer. So with that, we'll get right into the lab. Starting with our pre-lab, this is our answer to number 1, which asks us to create a truth table at every step for a 2-to-1 multiplexer. For number 2, we're using Circuit Lab to create and/or inverter gates using only voltage sources, resistors, and bipolar junction transistors. We're then using those to run through every iteration of the truth table for all the gates. So here we have 4 iterations of the AND gate, 4 for the OR gate, and 2 for the inverter gate. For number 3, we're then taking those logic gates and using them to create a 2-to-1 multiplexer in Circuit Lab. And once we've created it, we go through all iterations of its truth table. For number 4, we're then simulating our 2-to-1 multiplexer using Tinkercad onto a breadboard that is powered by our Arduino. We're then running through all iterations of the truth table by physically moving the 2 input wires and selector wires from low to high. For number 5, we are taking 3 2-to-1 multiplexers and combining them to make one 4-to-1 multiplexer using Circuit Lab. Here we are physically creating our 2-to-1 multiplexer as we did in pre-lab question 4, and again going through all iterations of the truth table by physically moving the 2 input wires, yellow and blue, and moving the selector wire, green, from low to high. For the final part of our lab, we are taking the 2 inputs of our 2-to-1 multiplexer and putting them into digital pins on our Arduino board. We are then sending different high-low frequency outputs to the 2-to-1 multiplexer while continuing to physically move the selector wire from low to high. We can see that when the selector wire is low, the LED blinks at the frequency provided by the B input, and when the selector wire is high, the LED blinks at the frequency provided by the A input. This proves that our multiplexer works as it should, and it is proven by the truth tables. And lastly, here is the Arduino code for the final section. Alright, that is it for Lab 1. Thank you for watching, and I'll see you next week.